only your name. So your name first, then your partner's name. Everyone should be filling this out though. Your name first and then your partner's name. Figure it out. They're sitting right next to you. All right. Then I'm just going to turn to where it says model. Would you follow along with me, please? This requires nothing from you but your eyes to follow and your ears to listen. Most people know that the Earth orbits or moves around the sun. Did you know that the shape of Earth's orbit is an ellipses? What? A type of oval, not oval. And did you know that part of the year Earth is closer to the sun than at other times of the year? Some people think that the weather warms up when the Earth is closer to the sun, but that is actually not true. The Earth is closest to the sun during the first week in January, right in the middle of winter for the Northern Hemisphere. And if you didn't know, the Earth is a sphere, right? So hemisphere is like half of a sphere, and we live in the northern part of the sphere. So we are in the Northern Hemisphere as well. Okay? So you can see that it's actually hottest when it's furthest away, which is interesting, right? It takes the Earth, you need to know these answers. It takes Earth 365 days to make one complete revolution around the sun. I believe that's a quiz question, so you might want to underline that. While the Earth is moving in this path around the sun, it is also rotating on its axis. Go ahead and rotate your Earth. What does it look like to rotate? Good, just like that. Just like so it's going around in a circle and rotating at the same time. So the axis is an imaginary line between the two poles. Do you see how there's kind of a circle at the top of your beach ball and a circle on the bottom? Those are your two poles. So if it's tilted just ever so slightly, it kind of is an angle, and there's an imaginary line in the middle that it spins around. If you've seen a globe, typically it's connected to something and it's can be spun, right? So spinning in a counterclockwise direction. So which way does it spin? Counterclockwise. Counterclockwise. So if you think of the clock as going this way, to the right, this is actually going to the left. So spin it to the left. Lefty-loosey, counterclockwise. All right, here's probably another question. Are you ready? The Earth makes one complete rotation. That is, it's rotating around its axis one full time every 24 hours. So a full revolution around the sun is 1 year. A full rotation on its axis is 1 day. Okay, so as the Earth rotates, different parts of it takes turns facing the sun. This causes day to turn to night and night to turn to day, right? But some part of Earth is always facing the sun, right? Additionally, the Earth tilts at about 23 degrees on its axis. As the Earth rotates on its axis and revolves around the sun, the northern and southern hemispheres each spend several months pointing toward the sun. So the hemisphere of the Earth that is pointing toward the sun receives heat and light from the sun more directly than the other times of the year. This causes the days to be longer than the nights and the temperatures to warm up. The hemisphere of the Earth that is pointing away from the sun receives less direct light and heat. During the months that this is happening, the days are shorter than the nights and the temperatures become colder. So obviously when we are facing away from the sun because of the angle of the tilt, we're in winter time. When we're facing towards the sun, we are in summertime. Sander Bailey, put it away and focus here with us. You're here and present, right? All right, so around December 21st, the southern hemisphere is tilting toward the sun. Remember, we are in the which hemisphere? Northern. And it is summer in the southern hemisphere around December 21st. Is it summer on December 21st here? No, it's what? Winter. Perfect. So since the northern hemisphere is pointing away from the sun, it is winter. The seasons are opposite. Around June 21st, when the northern hemisphere is pointing toward the sun and the southern hemisphere is pointing away. Around March 21st and September 21st, neither hemisphere is tilting toward the sun. The number of hours of daylight and night is about equal, 12 hours for each. These are what for the northern hemisphere? Spring and fall. Spring and fall. They're between winter and summer and winter. So around March 21st, it is spring in the northern hemisphere and autumn in the southern hemisphere. Again, the seasons are reversed around September 21st when the northern hemisphere enters autumn and it is spring in the southern hemisphere. It is spring right now. You got it. So today, you will model how the Earth's tilt affects the Earth's seasons. In the first part of this activity, are you paying attention and leaving your materials on your desk, please? You will use a globe and a light source to show how the Earth is positioned in space with respect to the sun for each of the 4 seasons. In the second and third parts, you will change the angle of the Earth's tilt and hypothesize how that change will affect the 4 seasons. You will conduct investigations to see these changes. You know, I think you need one more piece that I didn't give you. It's this. You do. That's the only one. Oh, thank you. Perfect. Please don't do things with that might destroy them because they're borrowed materials and have to be used in other classes. Really? Really. All right. So you're going to follow the directions. Hold your globe in front of your light source so you can see the glow of the light shining on your globe. Make sure the globe is tilted at about 23 degrees on its axis. So if you wanted to see what 23 degrees looks like, you can grab a protractor. So this is 90 degrees, right? Between here and here. 23 degrees is like this. So it's just a slight tilt. That's a huge tilt. What? Yeah. Well, think about it straight up and down, and then tilt it just ever so slightly. Do you see from here to here? Yes, I see what you're saying. Yeah. So think about it straight up and down like you would hold it, and then just tilt it ever so slightly to the right. Your teacher can help you find this angle using what you learned in the reading section. Position your globe in front of the light source so that you can show each season. Draw your observations below. Describe what you see. Okay, so here is what you need to do. Your purple cups have little slots in them, so you can position your sun and keep it in one spot. So you should put your, you have no idea what you're doing. You should be able to turn on your light source and keep it in one spot, but you might have to rotate it depending on where you are. Your globe, you can use that yellow spot this thing for, and position your globe so that it's on a tilt. So obviously it's not going to stay up and down. It's going to want to roll away, but try and turn it to a slight tilt of 23 degrees-ish. Obviously it's not going to be exact. That's okay. So then I want you to show what you would do as you rotate it around. So using this as a guide, you have kind of an ellipses, right? Use this as a guide to show what it might look like. And look at where the light is shining.
All right, put the flashlight on the cup now. Mine's on.
All right, guys, let me walk you real quick. After you do that, you're going to look at the next part. It's the same thing, but increase the tilt so that it is 45 degrees. So not all the way, but almost all the way. So just a little and then a little bit more. So then make a hypothesis. When I change it, I expect to see more light in these areas and less light here. I don't know. Because yada yada. And then rotate it around and through, draw what you see. And then look at the tilt when you don't tilt it at all. And then you have some questions to answer, okay? Be thorough, follow directions. Try it out, okay? I'll be floating around.